Let's use this topic 1.9 to really connect all of the multiple ways we've looked at how to evaluate limits over the past several topics. So what we're going to do today is we're going to spend this entire topic breaking down this particular function. F of x, which is going to equal, it's going to be a piecewise function with three pieces. And we're going to say it's going to behave like x plus 1 for x less than 0. We're going to say that the function behaves as 3 for x equal to 0. Or in other words, we're going to have the point 0, 3 on our graph. And then we're going to say that the function behaves like x squared plus 1 for all x greater than 0. And what we want to do is we want to look at how we can evaluate the limit as x approaches 0 of my f of x. And really we've learned three main ideas when it comes to how we evaluate limits. The first is how we evaluate limits graphically. Construct a graph and interpret or at least estimate the limit from those values. The next way that we looked at it was we looked at how we can evaluate limits numerically, where we construct a table and we get really close to 0 and evaluate the limit that way. And then lastly, the way that's really most efficient, especially if we're comfortable with some algebra skills, is we looked at how to evaluate limits analytically. Now these first two bullet points, graphically and numerically, those are estimations of limits, and I'll kind of talk about that as we go through them. The analytic side, that actually provides a verified evaluation of that limit. So these next three videos, we're going to find the limit as x approaches 0 of this function in each of these three ways.